Application virtualization is software technology that encapsulates computer programs from the underlying operating system on which it is executed. A fully virtualized application is not installed in the traditional sense, although it is still executed as if it were. The application behaves at runtime like it is directly interfacing with the original operating system and all the resources managed by it, but can be isolated or sandboxed to varying degrees. In this context, the term virtualization refers to the artifact being encapsulated, which is quite different from its meaning in hardware virtualization, where it refers to the artifact being abstracted. Description: full application virtualization requires a virtualization layer. Application virtualization layers replace part of the runtime environment normally provided by the operating system. The layer intercepts all disk operations of virtualized applications and transparently redirects them to a virtualized location, often a single file. The application remains unaware that it accesses a virtual resource instead of a physical one. Since the application is now working with one file instead of many files spread throughout the system, it becomes easy to run the application on a different computer and previously incompatible applications can be run side by side. Examples of this technology for the Windows platform include: benefits. Application virtualization allows applications to run in environments that do not suit the native application. For example, Wine allows some Microsoft Windows applications to run on Linux. CDE allows Linux applications to run on Linux distros in distro-agnostic way. Application virtualization reduces system integration and administration costs by maintaining a common software baseline across multiple diverse computers in an organization. Lesser integration protects the operating system and other applications from poorly written or buggy code. In some cases, it provides memory protection, IDE-style debugging features and may even run applications that are not written correctly. For example, applications that try to store user data in a read-only system-owned location. It allows incompatible applications to run side by side, at the same time and with minimal regression testing against one another. Isolating applications from the operating system has security benefits as well, as the exposure of the application does automatically entail the exposure of the entire OS. Application virtualization also enables simplified operating system migrations. Applications can be transferred to removable media or between computers without the need of installing them, becoming portable software. Application virtualization uses fewer resources than a separate virtual machine. Limitations: not all computer programs can be virtualized. Some examples include applications that require a device driver and 16-bit applications that need to run in shared memory space. Antivirus programs and applications that require heavy OS integration, such as window blinds or Style XP, are difficult to virtualize. Moreover, in software licensing, application virtualization bears great licensing pitfalls, mainly because both the application virtualization software and the virtualized applications must be correctly licensed. While application virtualization can address file and registry level compatibility issues between legacy applications and newer operating systems, applications that don't manage the heap correctly will not execute on Windows Vista, as they still allocate memory in the same way, regardless of whether they are virtualized or not. For this reason, specialist application compatibility fixes may still be needed, even if the application is virtualized. Related technologies. Technology categories that fall under application virtualization include: application streaming. Pieces of the application's code, data, and settings are delivered when they're first needed, instead of the entire application being delivered before startup. Running the packaged application may require the installation of a lightweight client application. Packages are usually delivered over a protocol such as HTTP, CIFS, or a TSP. Remote Desktop Services is a server-based computing presentation virtualization component of Microsoft Windows that allows a user to access applications and data hosted on a remote computer over a network. Remote Desktop Services sessions run in a single shared server operating system and are accessed using the Remote Desktop Protocol. Desktop virtualization is an umbrella term that describes software technologies that improve portability, manageability and compatibility of a personal computer's desktop environment by separating part or all of the desktop environment and associated applications from the physical client device that is used to access it. A common implementation of this approach is to host multiple desktop operating system instances on a server hardware platform running a hypervisor. This is generally referred to as virtual desktop infrastructure. See also, workspace virtualization, portable application creators, comparison of application virtual machines, shim, virtual application. References